So today I am going to discuss about this machine. So basically we see this machine in quantum computer as a quantum computer. So basically this is called dilution refrigerator. So today I am going to discuss about the function of this machine, how this machine works. So before going into that machine, I am going to discuss about this phenomena, which is the main concept about the key function of that machine. So basically in that machine we use helium 3 helium 4 mixer. So as we see in this graph that below a certain temperature, below 1 millikelvin, like sorry 1 kelvin, there is a phase separation. So it's happened around 800 millikelvin. So so we can see that below it's around 2.2, just above the 2 Kelvin, the helium 4 became the superfluid. So, as I in mentioned that we use helium 3 and helium 4 mixer in that refrigerator. So, as it goes down around 800 millikelvin, there is a phase separation. So, there is a two phase. One is the normal fluid, the helium 3 rich phase, and there is another phase which is in this part. So this is helium 3 helium 4 mixture, and the concentration of the helium. So in x-axis this is concentration of helium 3. The concentration of helium 3 in helium 4 became very less. It's around 6.6%. So basically, in this case, there is a there is two type of liquid in the dilution refrigerator. One is the helium 3 phase, which is top of the mixture of helium 4 and helium 3. Helium 3 is present in is around 6.6%. So now the this machine come. So basically, there are multiple stages of temperature. So this is around 50 Kelvin. This is around 4 Kelvin. So this still it's around 800 millikelvin. This is called cold plate. It's around 100 millikelvin, and this is the mixing chamber. So here where the researchers are doing their experiments. So it's shown there that this is the qubit chip. It is inside this tube. So this is the type of shield which protects our qubit. So basically, there are two type of cooling process. So initially, it's cool down these two plate 50 Kelvin and 4 Kelvin. So it's by pulse tube cryocooler. This, these two plates are cooled by pulse tube cryocooler. This is the part of pulse tube cryocooler. So when this the two plate goes around 4 Kelvin, the actual dilution process start. We are introducing this helium 3 helium 4 mixture by the condensing line. It is inside this, so it is not clear here, but the helium get liquefy at below 4.2 Kelvin, so it's mandatory to keep the temperature around 4 Kelvin. So after that we can introduce the helium 3 and helium 4 mixer. So then there is some heat switch. This is the heat switch. This turn off. So basically it's isolate this three part from these two part. So when we are introducing the helium 3 and helium 4 mixer, it's go down by this line and come out with this line. So basically what happens that this is called also dilution unit. So basically, when the helium 3 and helium 4 came down by this condensing line, so there are several heat exchanger, which so this is the heat exchanger. There are several heat exchanger between the plates. So it's cool down helium, the mixture of helium, the more down around the millikelvin range. So there are this is called his heat exchanger. It's mentioned in this photo also. And when this go down, and in this region this is called also mixing chamber, there are two phases of helium. So the top of the this liquid is helium 3 rich, and this bottom of the part is helium 4 rich. But in this case there are 6.6% helium 3 inside the helium 4. So this is in high pressure. This is like very narrow wire. We are introducing this helium 3 and helium 4 mixer. So when it goes down, as helium 3 has a higher vapor pressure, so inside this mixer, the helium 3 helium 4, so helium 3 will go out, and so this here the pressure from the gas pressure goes high pressure to low pressure. It's cool down automatically, and when it goes out, the hot liquid gets cooled down by this heat exchanger, and this flow will continue, and therefore this this liquid gets cooled down. And another thing is that in this phase the helium 3 has a higher enthalpy. So as we were create pressure inside this chamber, the helium 3 will go into this helium 3 helium 4 mixer. So for that case, it will take heat from the outside, and it will take the heat from the mixing chamber, the environment of the mixing chamber, and it will goes cool more cooler. The chamber will gets more cooler, and the cycle will repeats, and it goes down around 10 millikelvin.